Hello, good evening, and welcome to Eastern Academy. And we are into embedded system programming, week 12 on day one. We are discussing about microprocessor buses. Okay, so let me try to give you the good shape today. We have discussed so far, but today we'll give you slightly a good shape because you need to understand about where what buses are getting used and other things. Okay, so let us, as usual, get into board. See, we have two different things. One is information. Other one is knowledge. Other one is skill. And information, it's very good at the pictorial format and everything. You'll be able to get to know more. Okay, that is available everywhere. And that is what available on the all over the net. And knowledge is trick. From the information, how do you gain? You extract. That's a trick. Here is a problem. Everybody will give out different approach to you. So finally, you have to take a decision. The way you grasp is ultimately the knowledge. That means that you should be able to reproduce tomorrow. You basically have to understand what is, if somebody asks what is electronics, what is embedded? Oh, electronics means it is a box which takes electrical input and gives electrical output. That is about electronics. Then, and inside full of circuits. If you ask what is embedded, the same electronics where along with the circuits, if I have a computing engine, that is how in a short time, without elaborating that big theories or something, which somebody will be able to understand so easily. That is why what knowledge you have gained is important. If you that's why Einstein say, if you cannot explain it simply, it means that you have not understood it properly. Okay, that's the way the thing knowledge. But skill is the one which is the amount you practice. The amount you practice. Okay, so for example, if I talk about UART, that has three. One is information. What is UART? Who invented it? Why is UART? All those things. These informations are not going to be much useful, but except initially you understand that. Second, UART as a knowledge. You'll say, oh, it's a serial bus. And it goes with the start bit, then 8-bit and stop bit. And there is a parity. And we have an agreement on baud rate. That is in one time, 1 unit of time. That is 1 unit is 1 by baud rate. If I say baud rate is 1000, for example, then 1 by 1000 is 1 millisecond. In 1 millisecond, I'm going to send one bit, start or stop or everything. That is called 1 unit. So that is about right. This is the knowledge. This is fine. But you know one thing, this will be there always in the books or everywhere. This will be there in your brain for some time. If you want to keep this in a long time, then you have to do, you want skill, practice. How do you practice? Connect two controller, write a program, transmit and receive. Am I right? So everything you have to do now. You have to have a 3. This is available in, you go net. It's available in net. Previously, it used to be in a book. Today, I don't think so. Everybody is using a book. If you use a book, it's good, but we don't. We don't literally no time. So net is providing you very good information, but also there's a problem. You get you have to choose the right information. That's quite tough. Then knowledge. We discuss in the class, and from the information from the YouTube, you have so many things. So many places you will be able to get the knowledge. But skill, it's only you. You have to practice. You have to practice. Okay, we will discuss about, I'm discussing about only 2 of them, knowledge and skill. This is what we discuss. That means that, see here, we go back to the drawing board. I have a microprocessor. I have a controller. I have a controller. The controller does so many jobs. I dedicated to explain all the controllers sometime from next week. I'll disclose various controllers: display controller, hard disk controller, USB controller, so many controllers, how they are working. You should know that what they do actually. But we discuss very simply. We have discussed about a very small controller, which is called LED controller. One of the easiest. This LED controller has 1 register. How many register? Only 1 register. And whatever you write there, based on that, this controller will make the LED blink. You do not have to do anything. What I have to do as a microprocessor or as a CPU, this guy will write here, but this is part of my system. So I have a ROM, I have a RAM. Each one is having some address. ROM is having starting from 000 to 7FF. That is 32K. And RAM is having from 8000 to BFF. That's about 16K. And this guy is starting from C00, only 1, because I have only 1. So this is my whole memory map. Now what I have done is, I have a small chip select logic, whose address is C000. So address lines, 16 lines are going there. How many lines? 16 lines. That's very important. 16 lines are going there. And here, if it matches with C1000, if I write a program, char star X, X is equal to 0x C000, star X is equal to 50. Then what will happen? Microprocessor will put the 16 address line C00, and data lines he will put 50, and he makes write as a 1, read as 0, because I'm writing. Now what is happening? The write goes, this both goes to the latch enable, and this data goes as a data bus. So this is latched here. Now you see here, to write a 50 on the controller, that controller is having only one signal and the 8 data bus. I need to have 16 address lines, and I need to have 8 data lines, and I need to have these things. And people thought, but once I write it, that is going to blink. I'm not going to do anything. People thought, why do I waste so much of wires? Understood. We had 2 problems. One is, I told you initially about timing. That is, the moment the CPU become faster CPU, then the timing will not match. So what we did was, we did a small thing here. We had a CPU or microprocessor, and we had a bridge. Bridge will take the fast one, and it will make the slow one. Then they thought, I have 16 wires, I have 8 wires, I have write, and I have read, all of that. The input of bridge also same. The only thing is, this is fast, this is slow or standard. This, you keep on increasing the speed, CPU to 1 gigahertz, 2 gigahertz, 4 gigahertz, but this output will never change. This will be always, let us say, 100 megahertz. Never changes. So I need not have to change anything here, but CPU will be running faster. Now, this, if you go in deep on computer architecture, this information will be very handy for you. But right now, next problem came. Next problem was, if you have to communicate long, why should I have so many wires? That is what the last class we have discussed. We have discussed that from the microprocessor, I had only 1 wire. I had only 1 wire, not microprocessor, from the microcontroller. I have a latch, only 1 wire. This is called TX. And there's 1 wire called RX. I could communicate using a start bit and a stop bit and 8 bits. Okay. So this, what we discuss. Once again, I'm telling you that if you have to remember this knowledge, you have to start practicing more. We will discuss. I have given a project of, we had initially we had C programming that has about 55 problems. There, the 55th problem is a calculator. Same way, in the embedded system programming, on the passive programming, LED and switch, then comes 7-segment, then comes keypad, then comes LCD. LCD is sort of, it's not passive, but we take it passive. Then it's one of the easiest controllers. Only you have to write only few things. Then the last project is calculator. If you could do these things by yourself very comfortably, then you will go to the any level, next level easily. You have to be very comfortable. Okay, you should not have. If you have any doubt on the path, you ask me always. Okay. And there are 2 methods to do that. One is you can use your any hardware, or as I told you, the simulation. Simulation have some drawbacks. Please understand. It will not be. This will not be 100% same as hardware. That those days will come shortly. But right now, it's almost about 80-90% same. Otherwise, I will not suggest you. Okay, and this is helping you to this be the first stepping stone. Understand? Now, once they achieved the serial one, and this for a very long time, then suddenly one day there's a company called Philips, who are the very popular people in the audio, you know that audios and BTVs and everywhere. Within the circuit board, they had something called volume control. And there's something called brightness control. There are so many ICs. For every IC, this microprocessor was controlling through address and data. Then they found out in the board, in the PCB board, they have so many wires. Then they thought, why do I have to have so many communication? Why not I do it in a very short wires? In that short wire, they have come out with a communication called a serial communication. Like UART. Like UART. But only one difference is they have used two wires. See, I'll tell you what is the difference. The moment I tell you a difference, you will understand. In UART, please understand, in UART, I have a switch and I have a bulb. Please understand only this much, nothing more than that. You may call this is a transmitter. This is called receiver. Please understand the concepts are very simple. The only thing is what I am trying to explain to you is that you understand concept and get the information from anywhere. Concepts are very important. I have one switch and bulb. I on the switch to wake him up. So on, start. Then we have agreement. We have agreement. The agreement is every 1 second. That is what you call baud rate. Then start will be for 1 second. Then I'll send some data 0, 0, 0. I off for 3 seconds. 1 second. 1 second. 1 second. Then after 1 second, I make it as a 1, 1, 0, 0. 1 second. 1 second. 1 second. 1 second. 1 second. Totally how much now? 7 seconds. Now let us assume that we are doing the even parity. So there are 2 ones are there. So I make this as 0. Parity bit as 0. Then stop bit as 0. So I sent 10 bits. It took about now for me. That means that I just on off the switch. There's nothing. I just push the switch. This normally we do the experiment in the schools. We try to teach the person. We have a room. We ask the person to sit here and we give a switch and the other person to watch the bulb. And here we'll give a number to him. 10, 10, 1110. And that guy should find the number. If they find it, they're too good. Same way, that guy is having a switch. This guy is having a bulb. This we do it in the schools to make people, students to understand about the serial communication. So you can do manually. Okay. But you do manually here, or you make it as a pin of a port. And through your microprocessor, you write a software to write here. It doesn't matter. Okay. I'll come to the microprocessor part next. First, we'll go a concept. This is what happened. We know that. But the problem was they found that hey, there's a start bit, there's a stop bit, there's a parity bit. To set the 7 bits, I waste 3 bits. Okay. And also, the problem is I have to tell everybody well ahead what is the speed. I cannot change the speed. Suddenly I change the speed, you are gone. So the problems are all 2 problems. One is if I send 1 second, you have to say 1 second. That agreement has to be met very clearly. If you don't meet the agreement, then you're gone. Okay. If you don't have the agreement, you're gone. The same way, I have 2-3 people. Okay. And each one is at a various speed. Then I have gone. That it become too difficult to find out that who are all different speed and everything. Then people thought, okay, let us not do that, man. They come out with a new concept. That concept is a very, very nice concept. What they have done it is this. What they have done it is, I have a switch. I have a switch. And I have a bulb. All the same. I am a transmitter. I am a receiver. There's no same. No difference at all. Both are same. The only difference is when I on the switch, there he accepts. So our man here is watching this bulb. But here, our man will never watch this bulb. He will never watch. Because we had one more switch and one more bulb. Okay. He'll be watching only this switch. He'll be watching only this switch, this bulb, not this bulb. Am I right? What will I do if you want to transmit 0 here? See, I want to transmit 1, 0, 0, 1, 1, 0, 0, 1. What will I do here? I will send the start bit first. Then I will send 1, start, 1, 0, 0, 1, 1, 0, 0, 1, and stop. Okay. Now here, what will I do? Same thing I will do. I will take the same one here. I will on it. The bulb will glow, but he will not accept. See that? I don't set the start. Please understand. I don't no start. I send the 1 here. This guy will receive 1, but he will not accept it. He will accept only if this bulb goes on. When the bulb, he'll be watching this bulb. When this bulb goes on, then he will go and check here. Oh, this bulb is on, put 1. Then I will make this bulb off. After he accepts, he will come back. He will come back. Then he'll wait for once again off to on. What will I do here? Now I said 0. I off the switch. Now this bulb is off. But he will not accept. Once again, I will push the switch. This guy pushes the switch once. When I push the switch, when it goes from off to on, then he will go there and take over. Bulb is off, put 0. Then I will once again, then he will come back. Now it goes to off. He'll wait. Now what will I do here, this side? I will once again this off still. Then I will once again make this switch on and off. Then make 0. So understand, I have to push the switch 8 times on and off. This case does not bother about your timing and all. So you can be at random timing. The width can be anything. It doesn't matter. Okay. So you can call this as a pulse. Okay. But understand now, here the advantage is, whenever I press it, okay, that guy is going to receive it. Okay. There's no issue at all for him. So he does not have to. In this case, the UART case, if I say the speed is 1000 baud, that guy has to be baud rate is 1000. If it does not match, it does not work. In this case, this guy speed is determined by this guy. That's why this is called asynchronous communication. He can start sending data anytime. That's all he switch, only one wire. Here, this guy is depending on this guy. This guy has to be synchronized with guy. That's why this is called today in the serial communication, as we discussed previously, USB. This one, SPI, I2C, Ethernet, CAN. You take anything. All of them are synchronous communication. Only UART is asynchronous communication. Okay, please understand, only UART is a asynchronous communication. That means that for asynchronous communication, I need only one wire. For only one wire. On synchronous communication, I need two wires. People call clock, I generally call control. Now, here I have to tell you something. I can use the same wire to transmit data, and same wire can receive data. Let us assume the communication like this. I have A and B. A only can talk. B only can listen. This is called simplex. This is called simplex. All our broadcasts are like that. In a TV broadcast, everything is like all are simplex. Somebody is transmitting, you are listening. Correct. No timing and no control. Okay, that's it. Asynchronous. Timing is there. See, actually, unfortunately, that 9600 baud rate, what you are fixing, it is synchronous only, but they're calling it as asynchronous. A radio, all those things are called simplex. One guy transmit, you receive. But sometime, like you and me, let us say we are meeting, we are talking. When I am talking, you cannot talk, because we two talk, there's a confusion. So there's this common wire. I have a switch and I have a bulb. And you have a switch, you have a bulb. So when I on the switch, your bulb will glow. When you on the switch, my bulb will glow. But the problem is we cannot do simultaneously. Then there's a confusion. So I will talk, finally I'll say over. Then you will talk. That's why you know that all the police people will have it, a wireless thing. I'll be talking, then he'll say over. The other guy will talk. This is called off duplex. Duplex means A can talk to B and B can talk to A, but not simultaneously. Not simultaneously. That's why it is called off duplex. Understood? Next one is A can talk to B. There's a switch and bulb, and B can talk to A. This is called full. There's a separate wire for TX, the separate wire for RX. This is called full duplex. Okay. Actually, your USB, I2C, these are all off duplex. Your SPI, UART, all of them are full duplex. Ethernet started as off duplex, but nowadays it's full duplex. Okay, so we'll discuss all of them. What is there? So your I2C, for example, I have a signal and I have a clock. Your SPI, I have a signal, I have a clock. This signal is both. We'll discuss now how it is. This is pi. That's it. Okay. Now, what Philips did was they had a microprocessor, they had a clock, they have connected multiple ICs. They connected multiple ICs to the clock. Then there's a data clock. It goes to everybody. See that? Like your, I told you on that day, like a microprocessor, we have address bus, it goes to everyone. And you have a chip select logic, which decides which IC it is. So we call this as a bus. Now here also same thing. See here. When I transmit one here, and when I pulse the clock, then this guy also get one, he also get one, he also get one, he also get one. When I make this guy a 0, then I pulse it. Then this guy also gets 0, this guy also gets 0, all of. See, there's a big difference here. There is something called listening, accepting. There's something called listening and accepting. Okay. Now, these guys are listening everybody. When this guy talk, that's why they call this as a master. We call these as a slaves. We call them as a slave. Okay. Now, I told you that when I send a signal, all the people are listening. But before that, I have to do a wake up. I see, remember one thing. I told you very clearly. You see, please understand this. What I had, see that if you remember the thing, I had two switches. One is push button, one is this. That guy listens. See, this is called data, this is called clock. If you want to transmit one, what I do now, I put the switch on. The bulb is on. So this guy will get one, but he will not accept because he will look at this one to go up and up. I push the switch. That means that first I change the data. So first I change the data. I make the data as 1. Then I make the clock a small pulse. Then I make the data as 0. See here. Then I make the data as 0. I make the pulse. And make the data as a 1. I make a pulse. See, understand one thing. When the clock is high, data do not change. I change the data, then I, for example, let us make a thing very clear, man. Now you understand. This way, I have a microprocessor. I have a port. And this port address is, let us assume that 60, whatever it is. They say 8-bit port, latch enabled, 8-bit port. This is 8-bit port. I have a, let's take only 2 pin. We call data and clock. Okay, we can put serial data, serial clock, and serial data clock. That's why they call the name. Now, see here, I want to transmit 1, 0. Let me erase this also, then you will understand. I want to write 1, 0, 1, 1. Let us take a small one. I want this. I put char start I2C because I'm using I2C. I2C is equal to 0x60. There is a latch address. Now you see here, star I2C is equal to, I write here 0x01 because this data is 1. This is 1. 0x01 means 000 0, 0, 1. The first bit is STA. I make 1. So now this become 1. 1 SCL becomes 0. Okay. Now what I do here, star I2C is equal to 0x 03. Now I make this guy also 1. That means that I'm making the SCL 1. So I make first STA 1. Then I make SCL as a 1. Then I make star I2C is equal to 0x 0, 1. I make this guy as 0 once again. So what I don't change? I don't change the STA. I don't change the data. I change. So I have shown you using a switch. Now I have shown you how to do it with a small program. Listen, please, if you don't understand this program, let me know. How I am sending one bit, only one bit. If I have to send the second bit, I'll make this as a 0. I'll put a copy the same thing. I'll say right side is star. This is for 0, sending 1. Then I say I2C is equal to 0x 0, 0 because I'm putting 0 now. Then I put star I2C is equal to 0x 01. Sorry, 02. I make this case a 1. So now the SCL will go 0 to 1. Then I put star I2C is equal to 0x 00. So first I did 1, then pulse. Then I make 0 pulse. So I do not change that. Now this is I transmitted 1, 0. Now I want to say 1. Do the same thing. You can do it in a loop also. That's all very interesting. That's why I say that I told you now. If you want to understand everything today, you have to understand only through programming. That the day 1 onwards, our program starts. I'm repeatedly telling that master C programming. I told you, don't mistake me. If you have slightly, see, due to so many problems, you have n number of problems. It's not a small. You may be working somewhere and you have a student, everything. If you have a problem, don't worry. I'll be conducting the same session on practice. The next session, weekend batch, attend the lecture. If you say that, no, I don't know. Somebody is even some of the people in the first batch, you're attending my third batch also now. I'm giving so much of flexibility to you. You can attend any of our lectures, but you have to win the game. You have to win the race. You have to win the race. The winning is very important. I will give you all the options. I never say that, no, you cannot jump from batch 1 to batch 2. No, I don't say. I never say that from batch 1, batch 2, you have to go. You have to pay extra money. No, I don't say. Okay. I never say. So I am very flexible. I want you to learn to go out, but please help me. Please help me to master C programming. That's on your hand. I told you from the day 1, that is a skill building. You cannot, I can do only this much help, 1%. Remaining 99% is your effort. Any skill, that is a trick. And this skill is giving you money. This skill is giving you money. I referred one of our candidate to one of the MNC company yesterday. You know what the message I got back? Balaji, send him. I will discuss and give an offer. He said he's never even talk about interview. Understand? That level of interface I have with people. But please understand that. These are all very simple. Understand this code. No, why I'm talking to you is very, very clear now. You will understand that now. Why I spoke to you now, this is a very clear. It's like this. See, I have a microcontroller. See that I have a microcontroller. I have a microcontroller. I have an output port. I have output port. Sorry, I use only 2 pins. I don't use other pins. Why should I use other pins? I have other pins. STA, SCK, or SCL, whatever it is. And I have an input port of 8 bits. And in the ROM, you are writing a program now. What I told you now, that program you write to send the bit. And I told you the data is 1100111111. That data you're going to get it from the input port. This is your input port. Then I have another microcontroller. This guy's output port is connected here. You understand? Okay. Now I give the data here. This guy, what are you doing now? Both of them are microcontrollers. But this microcontroller, by writing your own program, you are going to convert this as a I2C controller. See that? Where I need not to worry about the timing, SCL, everything. I will give data 10111001. This guy will do that. Now you have a one Arduino board and the other Arduino board. You connect them. Done. You create your own I2C controller. Now you understand how do I design a controller? That's why I told you that how do you write the program here, star I2C and everything. These are all quite simple things, but only thing is there are two things. One is time. One is, even though you have a time, sometimes you don't like to take the step here. You know what stops you? I will tell you only one thing, not technical. Only one thing will pull you in all the embedded system programming exercises. Only one thing will pull you down. C programming. Your C programming will skill make you to procrastinate this. You'll be very surprised. There's nothing. You know that see, the trick here is that I'll tell you the trick. What is it? Now, let us assume that. Let us start here. I have a microcontroller. Both of them. I have a bus here, SDA, and I have a SCK, SCL. Connected. Now, right now, we'll make it as only one way. Once you understand one way, you'll be able to understand the other one. Okay. Now, what happened? You transmit data 101101. But they thought you suddenly starting. You cannot do that. They want you to wake up. Okay. The wake up mode, we have agreement. The agreement is this. The data will be during the clock is high. During the clock is high. Data will not change. So I change the data, then I change the clock. Let us say I make it 1 and I change the clock. That will accept 1. I make it 0, then I change the clock, pulse the clock, then I'll accept 0. Then I change it to 1, I'll put the clock. So I change the clock high and low, the signal, only when data is stable. But initially, both the lines are always 5 volt because they pull the line. They put the resistor here and pull up. So both the lines are always 5 volt. I'll discuss about what is open collector next. Don't worry about that. Why you have to have a pull up. So now, right now, when you take any 2 signals of SDA, SCK, SCL, they will be 5 volt. They'll be 5 volt. Now, they want to tell the guy, I'm going to change some data. Okay. I'm going to change some data. I'm going to send them. I'm going to send some data. So be alert. That's in what we call start bit. Here, what they have done, when the clock is high, when the clock is 1, and this is your when both are 1. Our rule is clock data should not change when the clock is high. That's what we did. But only one condition: during the start, when the clock is high, data will become 0. When clock is high, data becomes 0. So when this happen? When there is a start. So this guy knows that, oh, right, man, our man is going to send something. He will wake up or start. Same way, when it is completing, finally, that time he will make, when the data is high, clock is high, this guy will become, after I complete all the transmission, I go 0 to high. This means stop. So please understand, in normal condition, the normal condition, I should not change the data when clock is high. When clock is high, data should not change. Data should be stable when clock is high. But in start condition, when clock is high, data goes from 1 to 0. Start. The stop condition, when clock is high, data goes. That means that this guy will say that, hey, operation is completed. Okay. Now, I've told you that I've connected in our normal microprocessor. Correct. In the start condition, this is the thing. That is, when the clock is high, when it goes down, that will give an interrupt, a wake up. Correct. When I say pull up means the wires normal condition, this will be 5 volt. When I don't transmit anything, both will be 5 volt. That's called pull up. When I don't transmit, that gate don't transmit, that lines are going to be pull up. Okay. Typically, these are the small information which will be. Somebody asked now. You see that he's asking very good. It's normal is a 5 volt. This question will be asked in the interview. To know that you know I2C bus or not. Then the other one, what is the start? What is stop? These are the things will be asked in the interview. Okay, these are all the small points which asked in the interviews. Okay, so no, what I'm trying to tell you is that what everybody will tell you is that how to use I2C and SPI. Am I right? I am slightly different. I want you to build the I2C controller. I want you to build the I2C controller. These are all the this is not a very big investment. These are not now, after you've done the project. After you've done the calculator project. Don't step in now. Don't do too many things. You can do only one thing. After you complete the calculator project using the keypad and the LCD. After you've done the calculator project, I'll say go ahead. Then you can start getting into the thing. Never stop. Keep doing. Keep doing these things. Yeah, I will bet You will get one day, your curve will become like this. Suddenly you will become like this. You will never know that. You will never know that when you are going to rise. The moment you see, you know one thing, what is this rise? What is this rise? You may not know that. I will tell you exactly. Till this time, you have to do to believe. You have to do to believe. You have to see to believe. Understood? But after this time, here, you will start believe when you start reading it. You know that this is all possible. That means that you are gaining so much of expertise. Okay. Afterwards, if you just see a program, you know that, oh, this program will work, man. This program will not work. Okay. So I'm trying to tell you the very good secret. Never stop. Whichever company you work, wherever you work, have a lab. Have this, you know one thing, this I2C, this SPY, these are the questions even asked in the Intel. If you say that I have done I2C controller using the microcontroller, this project I'm telling now, how to use one microcontroller, other microcontroller, I2C controller. You did this project. You explain this setup to Intel or Qualcomm or any company. You are selected, man. I will bet you are selected. They will ask you so interestingly what you have done. They know that. Oh, if you're not, but you do one thing, at the other side, you should have the RTC controller, standard I2C controller. You know one thing, they will immediately come to know that without proper understanding of I2C, you cannot implement the I2C in the software. Done, man. You can this alone, if you could able to spend the time with them, the same method you want, the same method I2C, the same method SPY. You know one thing, after that you don't need Balaji at all. You said, sir, I will do it everything. If you complete these three, I will bet you don't need me at all. You will understand everything. And afterwards, the curve will become too good. Whatever you see, you will see the growth. So don't take things as a very light. What I'm telling you all, there's certain industry secrets which nobody will tell you. Everybody think that they underestimate you. You cannot do that. They said that these are all implemented by the some company, man. If you ask anybody, you go to any institute and ask anybody, how do I design I2C controller? They will say that this is a VLSI project. And that is done by the hardware people. Okay. But that is very easy, man. That is very, very easy. I tell you, because this all I have done it. I did it everything. Why I'm telling you all these things are all, I'm nobody. I'm a very average student. Could able to do well industry because of this. This is very, very nice thing. So please, after your project, visit back, come back. Now I wanted to ask one more thing. I just wanted to ask the thing. How many of you have gone back our electrical exercises 1 to 10? All the exercises, how comfortable you are today? Go and check. Today, go and check once again. How comfortable all our old exercises. That's very, very important. You have to be very now and then you have to refresh. Everything, man. Your EEPROM, your temperature sensor, your accelerometer, your RTC. You are today the whole world is your even a power supply controller. Everything is I2C now. Today, you know one thing. Please understand. All the MNC, this one SOC chips. All the SOC chips. Yeah, CAN is also the same. There's nothing. Once you know the I2C and SPY, CAN is very easy. I'll explain to you about CAN. Okay. After that, after explaining the I2C and SPY, I will explain to you CAN. There's nothing. You can understand CAN very easily. Okay. I will tell you the advantage of CAN. Now, CAN is going to be CAN is going to be gone another few years. Everything is going to be Ethernet. They say CAN over Ethernet. That will be surprise. Now, in the SOC, they do everything inside controllers, but outside temperature sensors, all those things are connected to I2C. That's why when you do the embedded Linux, everything, what the Intel will say that your knowledge on I2C is important. Your knowledge on SPI is important. They are very small bursts, you think, but they get you a job in every company because all the SOC, the outside things are all this. Yeah, that is your mistake. That is, don't do that. That is, don't do that. Okay, now you should not. I should remind you. You should have gone. You should have gone back. It is your job to get back to the problems and everything. That's why I ask you now. So please understand that the things are like this, so simple. That is, if you could make, let me write a program. Let me write a small program. You understand? Right now, this program, you do it. You say char star x, whatever it is, and char y. Y is equal to whatever number you give, 50 or something. Okay. You write a function call. Send y. Send y. You write a function called send, just only send. Then void send char. Okay. Now here you say you put the initialize the port, one output pin, only one output pin. There you connect a LED. There you connect a LED. And you send the data 50. 50 means how much? 0, 0, 32, plus 16, 48, plus 2. Am I right? 32 plus 16 is 48 plus 2 is 50. Yes, I put decimal. I didn't put 0x. Now, in C it is decimal. When I go there. Now, what you do here is, you start, when you run the program, okay, first the LED should on for 1 second. Then next to 1 second, LED should be off. Then LED should be on 1 second. Then off for 2 seconds. You take a clock and watch that. You write it. Whatever number you write, you go there. Okay. Or you have 2 people. Let somebody ask somebody to write the number. And you should find out here. Done, man. This is what all about your, you what? On SPI. How we are going to handle it? See, the problem is we have a lot of confusion. The confusions, don't worry about that. The first thing, understand delivery. Delivery is very important. That means that I am at place X. You are at place Y. I want to transmit a number, some number, 70, through the wire. Can you get it or not? If you can get it, then I can do anything, man. I can call 70 any meaning, that we'll discuss later. Can I send 70 or not? There are 2 methods here. One method is, I send 70. You should got it. If you have not got it, how do I know that? Whether you have received it or not? For that, you will send me the acknowledgement. So there are 2 methods. That is what. So that is a small tricks we will discuss. That means that one is called reliable communication. Other one is unreliable communication. Okay, for example, if we take I2C, that is reliable communication. Spy is unreliable communication. How? We will discuss. For example, if you study in the college Ethernet is there are two things. One is called UDP, TCP. UDP is connectionless. TCP is connection oriented. What is that? Okay, that we'll discuss. That same thing here. These are all small, but these are all very small. You get confused on the things. That is, don't get confused on the big things. The thing is that I transmit 70, can I receive it or not? This is called physical. There are two methods. One is asynchronous, other one is synchronous. In asynchronous, only one wire. In synchronous, two wires. Okay. Then, while transmitting, I have either simplex or duplex. In duplex, off duplex, or full duplex. Am I right? Go with very, don't try to don't think that these are all great. Spy, I2C are great. They are not at all great. They have come for sending the number from one place to other place. That's all. There is no difference between your CPU, sorry, microprocessor, and the controller or an IC. You are given an address and you given a data. The data goes there, then you give a write signal. He accepts. Where to write? You give an address. That's it. When you want to read, you give a read. Understand? Here also same thing. Here also same thing. I have a microprocessor. I give all of them. Address, read, write, and data. Understood? Now, this is coming as 16 wires. This is coming a one wire. This is one wire. This is 8 wires. Somebody here is converting them to one wire and sending it there. Okay. There somebody will convert that to this 16. 1. 1. 8. See here, they are all like this. Actually, they're like this. Okay, these are Chuma. These two are Chuma. They are actually middleman. Middleman. They are just converting parallel to this side. Parallel. Series. This guy is converting serial to. You know what? Yeah, perfect. Somebody has mentioned saving wires. I have only one wire. Instead of 16 plus 17, 18 and 8, instead of 26 wires, I use only one wire. Okay. How this is happening, you should have a good picture on yourself. That's important. The most important thing is your picture, mental picture. That is what I'm trying. I could see this half an hour job, man. Not even half an hour, I'll explain everything. Hey, take the controller, and this is what the spy registers. You write there, it will communicate to the RTC, you read it. But our job is very clear. I'm trying to give you the so generic approach. Tomorrow, when there's a new bus comes, somebody say one wire, two wire. You'll try to understand everything, what they are doing, what they are trying, what they are doing. Now go to net and try to get the information of I2C spy. Whenever you have a time, read it. What I'm saying, what they are telling, you don't understand, come to me. That's the way we discuss. Okay. Then I have a same thing memory. Understand? This is what happening. To save a bus, I appoint 2 extra people. That's what I'm telling you, that do them as your own microcontroller software. You have done. If you have done that, then you will never forget in your life. Okay. I don't want to help you here, because if I help you, you will lose the opportunity of learning. Now let us come to the 2 things here. Another important thing. The trick here is, I have one wire through which I have a switch. Sorry, bulb. I am TX. This guy is RX. But there is simplex. Then I cannot read from him. So what they have done, see here, they also have a switch. They also have a switch. And this guy also having a bulb. Then the moment I put switch and bulb, you think this is a full duplex. No. What they have done here is they have connected here. Now they made this one as a slightly bigger. Outside there is only one wire. That means that if I put the switch, my bulb will glow, his bulb will glow. When you put the switch, his bulb will glow, my bulb will glow. Am I right? Is it okay? But only trick here is, I send something, some numbers. Let us say I want to transmit, let us say 70, 40, 25. I send. Then he also received now 70. I'm only now on, I do that. I'm the master. He's a slave. He keep quiet. I send 70, 40, 25. You don't understand, I don't understand, but he understand. Oh, now master want to read from line 25. So he go and read from 25 line, and whatever data, he will transmit it. That time, I will keep quiet till he complete the transmission. I can tell you, let us say I have 2 people. I tell you, talk. Then you talk. When you talk, you will start with a start. And you will do stop. The moment you stop, when see that I will do thing, I will start. I told you start means I have a high clock, data is changing, high to low. That means that I told him that I'm starting. Now I sent to him some information and tell him you talk. Then after I told him talk, I'll keep quiet. How he will know? I will make the clock is high. I'll make data high. That means that I completed my over talk. Now what happened? I will go to the listening mode. Since I told him to talk, I will not, my switch, I will not control. Then what happened? What our man will do? He will control the switch. Then he will send the start, same way. Have the clock high and data changes. Start. Then he will transmit the information what you asked. Then he will make the this one clock. Then he will make the data high. He understands stop. Then this guy knows that, oh, our man completed. Is it clear? There are 2 people are now using commonly only one wire. 2 people are using commonly only one wire. Is it clear? If it is not clear, ask, let me know. But only thing is, both are masters in terms of transmission. Both can transmit, but only problem is this guy don't have a permission to start unless this guy says. That's why this guy is called master. Both are can transmit on the I2C. Both is having a same switch. Both are having same bulb. The only difference is that guy will not do it. That's a trick. Is it clear? Now, what government did? Who? Our Philips. They have connected multiple people like this. The same wire goes. Of course, the other wire also goes. SCL. That goes to everybody. This SCL also goes to everybody. Without clock, your I2C will not work. Now, this guy do the start. All the people will get start. Then all are wake up. And everybody is having the same one. Receiver and there's a switch. Receiver and the switch. All are same copy. Now, what our man will do? Hey, you take a number of 10. Your name is 20. Your name is 30. I will send the first number, 8 bits, as 10. All the people will listen. 10, 10, 10. Then they will compare with their name. This is my name, man. This guy will say, oh, I am 20. Master 1 from 10. Then he keep quiet. This guy go to keep quiet. Then this guy keep quiet because his name is 30. Master 1 from 10. And this guy will say, oh God, now I have to listen. Afterwards, see, you started. You did start. Then you just stop. Till the time, whatever you transmit will be listened, accepted by all the people will listen. But only this guy will accept. After he accepts, then he will take the necessary action. Okay. So this is, but there's one more problem. They don't know whether master one bit. See, we know that when the microprocessor is communicating to the memory, there are 2 bits. We have write and read. Write for reading. So these guys don't know, hey, you selected me. Now I have to write or read. What they have done here is on the 8 bits, 1 bit is called write bar read or read write bar. And 7 bits are called address. It is called device address. That means that like this, I can connect 127. Forget about 0. 126 devices can be connected. There are 2 standards. We will discuss later. 7-bit and 10-bit. In 10-bit, you can go up to 2024. Forget about that. Let us take only 7-bit now. So think of it. Now I have a master has 1 wire called SDA. I have 1 wire called SCL. And they are connected to multiple people. They are connected to multiple people. And this guy connected to all of them. Am I right? This guy is microprocessor. Sorry, this guy is master. I didn't say microprocessor. This is a microcontroller. Could be anything. These are slaves. Each one can have address up to 7-bit. Each one can have an address of up to 7 bits. So this guy address could be 78, 43, 29, 36. But only rule is because they all have a switch to transmit. So when this guy requests, if 2 people are having same 43, then both will start transferring. There'll be a confusion. So in I2C, no two devices should have a same address. Now, do you understand device address? That means that what will I do here as a master? First, I will do start. Then I will send the device address. I will do read or write. This is 7-bit. This is 1-bit. But after sending the 7-bit, I keep quiet. If let us say, I told you there is a pull up. See that. Now I have a switch here. Switch is, let's say, connected to ground, assuming. And I put the switch, it becomes 0. When I off means it's 5 volt. Now this guy also have a switch. When I don't put the switch on, it is going to be 0 volt. Now, let us assume that you put a start. That is, when a data is, clock is high, data is changing. Now you transmit the address. Let us say 25. No, 25. And you say read or write. This guy got it. So everybody got 25. Now this, all the people have done this way, done it. But that's a trick here. After he accepts the 8-bit, this is 7-bit. This is 8-bit. After 8-bit, this guy will tell him that, hey, you selected me. You selected me. For that, he will put this, he will press the switch. Then this guy become, sorry, not this, this one. This guy becomes 0 volt. So this guy understand that, oh, I got 0 volt. That is called acknowledgement. That's called acknowledgement. I got acknowledgement. So every byte I transmit, every 8-bit, after sending 8-bit, I'll keep quiet. It is the responsibility of the slave to send me the acknowledgement. For example, let us assume that I send the address 26. No, but no 26 is there. So all the people have received 26. And nobody is having 26. So nobody will press the switch. Nobody will press the acknowledgement. So this will be always high. The acknowledgement will be always high. So our man thinks, master thinks that 26 is not present. This is called we do scanning. Initially, every firmware will do the scanning of what are the I2 devices are there by this. It starts from 1 to 127. It scans all the devices. Okay. This is the way it does. Who are all present. Then they will find out who are all there. That we will discuss later. First of all, this has to be clear to you. If this is not clear, we cannot proceed further. I've given a simple idea of what is I2C. Let me try to make few recorded videos and send it to you by tomorrow. Much more clarity on this. Sometimes I'm very doubt, man. You watch any, there are wonderful videos better than me or there in the YouTube. I myself is surprised. What I'm teaching is they are too good. Somebody has given you the wonderful thing about explanations. Great professors. But the only advantage which I have is I will clarify your doubts. They are one way. Okay, I can clarify your doubts. So I want you to implement this. And whenever you say that I'm not able to do that, then I'll come. Actually, the whole program, I told you in the beginning of the class itself, I'm going to reshape the whole program from the 1st of 2022. Anytime you can join, anytime you can proceed, anytime you can go, and anytime you have a doubt, you can ask. Because without you get into the basic programming, you have come here, you don't understand. This is once again like a college. I wanted to get away from this. But you will be part of that. Don't worry. You will be part of that. You will be with me always. Your first batch will be always with me. Don't worry. I just started. Then only I realized. Now I'm realizing that even though this method itself is, I'm trying to put everything simple, but I'm not happy. This method itself will not produce you perfect person. I want you to sit before the interview with a confident, but this method will not get you that. Which it will do, but not within the 13 weeks. You have to spend some more time. Because you have a lot of, you allocating in time for me is very little. That's a problem. Okay, so 3 things we have discussed today. How do I make a controller? Okay. Second thing is, what is this all about serial communication? I'm doing the same thing. I'm giving the device address and I do write. Then tomorrow we'll discuss about data. The data part is tricky. That's why I didn't discuss now data part. I discuss address part. I discuss read or write. Then I didn't discuss about data part because that has to be discussed slightly different. That's why I didn't do that. Okay. This is only device address. Don't get confused. This is a device address. I will exactly match this with your microprocessor. Then you will understand these two are same. That's a trick. So any doubts you can ask me now. I don't want to explain the data. Data will take about another chunk of half an hour, which I can do it a day after tomorrow. Tomorrow I'll send you the video of this explaining. And I have a doubt. Somebody asking about floating point. Shall I make a floating point? A floating point is not directly much used in the embedded world. Can I make a lecture, recorded lecture of floating point and send it to you? Or do you want to spend that time on the class? Which one is preferable? Please let me know. Please let me know which one is preferable for you. Yeah, majority is saying recorded. That's good. Then I'll make a recorded one for floating point and send it to you. One advantage is the recorded one is I can go on my own face. I don't have a pressure to complete within this time. So I can take my own time. Thanks. I think people have at least understood that that unanimously people have said that recorded. That way I'm happy. That's good. But if you have one advantage is recorded one. Whatever doubt you come and you ask me. Okay. Next class we'll have a session. If you say that any doubt on recorded one, I'll explain to you. No problem. If you have a doubt. Yeah, I can do that. actually, HAL is we are implementing. You know one thing, you actually implement HAL. You don't know that. You know one thing, you don't know you are implementing HAL. I've already explained HAL. Do you know that? Can you believe it? I've actually explained HAL. Your output. Your output. You send some data now. This is called HAL. I will explain to you that what is this. Okay. I've already, you implemented HAL. You will be implemented HAL, but you don't know that is HAL. I will explain to you that what is HAL and what is the thing about output. I'm putting all the necessary point well ahead. But only thing I request is starting from electrical, come back to the, now you go back to electrical and see that you will start understanding a lot more better. And today, first somebody also starting also, can I start from the exercise 1 to 55? You can do that, or I will start giving you the same equivalent, another 50 exercises, same equivalent, where that will help you to reshape your programming culture. I'll give you more. Don't worry. Spend time with me. You put your time, whatever time you are going to spend. I'll make you all will be very, very useful. You'd bet. Okay, then. Let me, if you don't have any other doubt, I can able to stop the lecture.